Hello friends, my name is Anup Mayank. I am a software engineer and have worked with multiple teams for past 22 years. In today's talk, I am going to talk about time travel. I am not talking about time travel movies like Back to the Future, which is one of my favorite. Today I shall talk about time travel capabilities in modern data platforms, specifically comparing Databricks, Delta Lake, and Snowflake. Time travel is a powerful feature that allows organizations to access historical versions of data. This becomes extremely valuable for debugging, auditing, recovery, and even reproducing machine learning capabilities. As data platforms become more critical for analytics and AI workloads, the ability to reliably go back in time and inspect earlier states of data has become essential. With that, let's dive into it. All right, so exactly what is time travel? At a high level, time travel allows users to query older versions of datasets. Instead of only seeing the current state of table, we can access how that table looked yesterday, last week, or even at a specific timestamp. This capability helps in several scenarios, such as recovering accidentally deleted data, debugging failed ETL jobs, supporting compliance audits, and reproducing analytics or ML results. You can think of it like Git version control, but for data tables. This timeline at bottom represents how data evolves across multiple versions, while time travel allows us to query any historical point. Version 1, version 2, version 3, and current. So you can see that we can query at any point in time. Let's move on. Let's first look at how Databricks implements time travel using Delta Lake. Delta Lake maintains a transaction log called delta log. Every operation inserts, updates, deletes, merges, create a new version of the table. This transaction log stores metadata changes, file level history, and ACID transaction information. Because of this architecture, Databricks can reconstruct any previous table version. On the right side, you can see examples. Query by version number, querying by timestamp, and even restoring a table to an earlier state. One major advantage of Delta Lake is transparency and flexibility. Since it is built on open storage format, engineers have more visibility into how data history is maintained. It also integrates very well with large-scale streaming and data engineering workloads. Cool. Now let's look at Snowflake's approach. A Snowflake also provides time travel, but it works differently internally. Instead of transaction logs exposed to users, Snowflake automatically manages historical snapshots, snapshot 1, 2, and n, and metadata behind the scenes. Users can access previous table states, dropped objects, and historical snapshots. This SQL syntax is also very straightforward using timestamp or offsets. Snowflake additionally supports features like undrop, which helps recover accidentally deleted tables. Compared to Databricks, Snowflake emphasizes operational simplicity. Much of the complexity is abstracted away from users. This makes it very attractive for analytics-heavy organizations that want a strong governance with minimal operational overhead. As you can see, these are some of the queries like with offset, you can say select a star from cells at offset greater than equal to 5 hours from before. And with timestamp, and you can undrop tables. So that is the power of time travel in Snowflake. Moving on. Now let's look at the comparative view of Databricks and Snowflake. So this slide summarizes the key differences between the two platforms. Databricks Delta Lake provides an open lakehouse architecture, exposes transaction log-based history, and has support for engineering and streaming use cases. Whereas Snowflake provides a highly managed warehouse experience, uses internal snapshot mechanisms, and focuses heavily on simplicity and governance. Another important distinction is openness. Delta Lake works with open formats, whereas Snowflake operates more as a proprietary managed platform. So the choice often depends on organization's priorities, engineering flexibility versus operational simplicity. One thing I would like to add, now Snowflake is also adopting Iceberg format, which is an open standard from Apache. So this differentiation is getting a little bit removed. So let's look at next step. To conclude, time travel is an extremely valuable capability for modern data platforms. However, it should be used carefully. Organizations should configure appropriate retention periods, avoid overly aggressive cleanup policies. Now, these 2 points are important because if your retention period is very high, then you are storing lots of older data as snapshots you have seen, and it will increase your data cost. Or if you are doing aggressive cleanup, then you are losing cleaning up the older data which is stored as snapshot, and you won't be able to benefit from time travel. You have to document rollback procedures, and you have to combine time travel with governance and observability systems. Comparing between Databricks and Snowflake, so Databricks may be preferable when organizations need open architectures, heavy data engineering, or streaming workloads. A Snowflake may be preferable when organizations prioritize simplicity, managed operations, and SQL-first analytics. Overall, time travel significantly improves reliability, auditability, data recovery, and reproducibility for analytics and AI systems. So friends, that's all for time travel in Databricks and Snowflake. Please share your comments. Thank you.